This time we'll learn about the limit of a polynomial function. A polynomial function is any function of the form p of x equals t sub n x raised to n plus t sub n minus 1 x raised to n minus 1 down until c sub 1 x plus c sub o. Let a be any real number, then the limit of p of x as x approaches a is just equal to p of a. Note that we can get p of a by simply substituting a to every x in the polynomial. Now, how is this so? So let's see. Okay, so let's evaluate the limit of the polynomial. So the limit of p of x as x approaches a is equal to the limit as x approaches a of the definition of the polynomial. After that, we can apply the sum law. That is, we can distribute the limit to every term in the polynomial. After distributing the limit, we can now apply the constant multiple law. If you observed, every term in the polynomial has a constant in the form of c sub I, so c sub n minus 1, c sub 1, and c sub o. So we can apply the constant multiple law from the first term up to the second to the last term. We will leave the last term alone because this is a constant function. So we get this. We factor out the c sub i's from the limit. So we are left with limit argument in the form of x raised to a power. So we can use the power law. So we get the limit of x raised to n. Here we get the limit of x raised to n minus 1, the limit of x, and then the limit of the constant c sub o. From here, we can simply apply the basic limit theorems. The limit of x as x approaches a is a. So we will apply that to every term here. So that's why we get c sub n, a raised to n. Then here we get a raised to n minus 1. We get a. And this is just c sub o because the limit of the constant c sub o as x approaches a is equal to c sub o. Now, if you observe, if you rewrite, we get this. And if you observe, this is just our p of a. Hence, we say that the limit of p of x as x approaches a is indeed p of a. So here are some examples. The limit of 3x raised to 5 plus 4x minus 5 as x approaches negative 1 would be, when we evaluate the limit, we just substitute negative 1 to every x in the polynomial. So we just get this. And then we simplify. Hence, we get negative 3 minus 9, so negative 12. Therefore, the limit of 3x raised to 5 plus 4x minus 5 as x approaches negative 1 is equal to negative 12. So we do the same thing for the second example. We have the limit of negative 3x squared plus 7x minus 2 as x approaches 2. First, we apply the limit of a polynomial function, and then we simply do algebraic theorems. So therefore, the limit of negative 3x squared plus 7x minus 2 as x approaches negative 1 is equal to 0. So let's do a recap. What we learned today was to evaluate the limit of polynomial functions. So for any polynomial p and any real number a, we get the limit of p as x approaches a as p of a, or we simply substitute a to x in p.